Hello everyone and welcome to the COMP1511 Assignment 2 live stream. I'm hoping that people can hear and see us, and I'm waiting for it to reflect on my end. It has just reflected on my end. Awesome. And welcome to with me we have Rory and Clarissa, who are the Assignment 2 authors, and they'll be doing a run through of Assignment 2. Everything you need to know about Assignment 2, how to get started and how to get help. So over to you, Rory and Clarissa.
Hey, so Simon is called CS Pizzeria. And yeah, so let's go. So what we're going to be covering in this lecture is what is assignment 2 about? What does it cover? What skills will you be using? And then we'll be looking at the inspiration behind assignment 2. And then we'll be looking at the specification overview because we kind of have information in two places for this assignment. So we have it on the course website, just like how you guys had it in assignment 1, but we also have a .h file because that is integral to a multi-file project. And then we will be providing a demo of how to get started in the assignment, doing a stage-by-stage overview. And then finally, we're going to close it off with assignment 2 tips and questions for everyone. Okay, cool. So this assignment is about linked lists, a whole lot of linked lists. So while assignment 1's focus was arrays, assignment 2's focus is linked lists. So you guys have just learned it in last week's lectures, and we've just touched it in this week's tutorials and labs. So don't worry if you're not completely confident in them. We will cover everything you need by the end of week 9. And then, as you guys can see in the subtitle, we'll be doing a little bit of string stuff because it wasn't touched in assignment 1 because you guys hadn't covered it yet. So now we're going to be looking at a little bit of strings in assignment 2. If you guys need more examples of those, week 7 has lots in the tutorial, in the lab, and in the weekly test. Cool.
All right. So, inspiration behind this assignment with this awesome picture that I don't know who made. So this assignment kind of came, I came with this assignment like a rough idea of it. I don't know, about a year ago, I was sitting as a university student, thinking of assignment ideas instead of socializing, of course. And I came with just this restaurant idea, where I thought, okay, you could have some kind of like linked list stuff that goes on here where we've got like orders and ingredients and you're handling them as the programmer. And eventually this turned into being a definitely not a ripoff of Papa's Pizzeria, the fantastic AAA game, but for legal reasons, it's not actually. So this was the pitch for the assignment. Clarissa decided to include it in the slides. It's very, very terrible. But yeah, that's the inspiration behind it. And I know that for assignment 1, Alvin spent 20 minutes playing Stardew Valley, but I will not be spending that time playing Papa's Pizzeria, unfortunately. But go check it out if you can, if you guys have Flash to play it as well. But yeah, move on.
Thank you, Rory. So now we'll be looking at the specifications. So on the course website, you can find it super duper easy at the very top, assignment 2, you click on it and you find the spec just like how you did for assignment 1. It'll have a bunch of introductory and background information, just like the information that Rory had just conveyed to us. And yeah, so we'll also have lots of details of how to start and what each file does. And it'll have lots and lots of diagrams. So these diagrams are probably things you guys saw with your tutors and something you guys have seen in the tutorial questions. We'll be having loads of those in the assignment as well. And while the course website will have summaries, diagrams, and hints for each of the functions, pizzeria.h will have details and assumptions. So next slide, Rory.
Yep.
Yeah. And then because it's a H file, it will also have hash defines and function prototypes, which describe the input and output of each function. If you guys have looked at fractions in your lab exercises, you guys will have seen these really thick function comments, and we will have even thicker function comments for the assignment 2 because we'll be describing the behavior, specific examples, what each parameter does, what it will return, and what scenario it will return, and it'll have loads and loads of assumptions. And also, if we do make changes to pizzeria.h, there will be a version number at the very, very top of the specification on the course website to make sure that you have the up-to-date version. Yeah, okay, cool. And now Rory will demonstrate how to get started.
Yep, so just like with assignment 1, first stop that you go to is the assignment page, or the course web page anyways. There's two ways to make your way to assignment 2, either this big tab up here or just the assignment 2 there. So just click on either of those and you'll get taken to the assignment page, where you'll essentially just have like a bit of background as we were talking about before. Feel free to read through that, it's interesting. And one thing that we will note before we get into this, everything for this assignment hasn't been taught yet in lectures so far. So if you are like worried you don't know something, chances are that it hasn't been taught or it's just been taught recently. So just keep that in mind. But by the end of week 8, everything should have been taught by then. And you should be able to finish at least stage 1 with the stuff that you guys know so far. So the assignment live stream, you're either here live or you're hearing a recording. If you're here live, this is where it'll appear. If you're in the recording, you probably found it as you would be watching this. But yeah, a link to it will be here where you can just come back if you need to. So what is CS Pizzeria? CS Pizzeria is essentially you as a programmer writing a system to manage an entire pizzeria. So you'll be managing like the whole order concept of a pizzeria, where customers come in, they order pizzas, you complete those orders, you add ingredients to those pizzas, all that kind of stuff. So really interesting, a lot to do though. So there's a lot of moving parts in this assignment. In terms of stages, just like before, there's 4 stages. In stage 1, or in every stage, sorry, we have some kind of like diagram to explain what's going on. In stage 1, essentially, this is what your entire like representation of a pizzeria is going to look like. The important thing to note is that we have this Struct pizzeria. You can think of this as the actual physical pizzeria that we have in the world. And this will contain like all the information for it. So you can imagine the physical pizzeria, the restaurant itself, will have all the orders intact, right? And all those ingredients in those orders and all that kind of stuff. So in stage 1, and it's important to note here, we have this pizzeria, and then it also has a linked list of orders inside of it. Now, I know that in like the tutorials and labs, we haven't really thought of like putting a linked list in another struct, but essentially in this assignment, we're doing that. In terms of how that works, all you literally do is put the head of the linked list inside the pizzeria like this, which is our struct orders here. And then there's your whole linked list. So it's just like an extra level of struct being added there, but hopefully not too complicated. These diagrams should help you guys out a lot with like how the structure works. But if you have any questions, just ask them on the forum, ask your tutor, and we should help you. So this is stage 1. We have a struct pizzeria, contains a linked list of orders, and these orders have like various information such as like your name, or like a customer's name, the pizza, the price, time, and then the next pointer, right? Because we're using linked lists, we're going to have a next pointer that goes to the next order, and so on. So that's stage 1. Stage 2 gets a bit more complicated, and this is the stuff that we haven't gone over completely yet. But stage 2 will essentially be introducing an ingredients struct, and these ingredients are essentially going to be another linked list that get added to each order. So this is where it starts getting quite confusing because it's like 2 dimensions of linked lists, and that's exactly what it is. It's a 2-dimensional linked list. And I think that should be gone over soon in the lectures if it hasn't already. But what we're going to have now is we've got our pizzeria, just like before. We've got all our orders, and then each order will have its own linked list of ingredients. So don't worry about this for now. Once you finish stage 1, it'll make a lot more sense as to what we're doing. This is just to like show you guys what the future is going to look like. Then stage 3, we go even further and we add another linked list here, but I won't go over that too much because I don't want to add confusion to everyone. But basically, we're going to have another linked list, which is just the stock inside the pizzeria, and we'll be using that to do various operations. Cool. And then stage 4, diagram doesn't change, but we'll have extra things we need you guys to do, and we'll get to that later. So we provided you with a couple of structs just to work with. First struct is the pizzeria struct, and this will essentially, for now at least, only contain a pointer to the head of the orders. So we're going to have an orders linked list. This will contain the head of it essentially, or it will contain null, right? If we have no orders, it's not going to contain anything. We then have a struct order. This is the most important thing, I think, for students to, for you guys all to understand. A struct order will essentially have all the information about an order, and then next pointer to another. what you'll notice is that we haven't actually included any of these like extra variables like price or time or anything like that. That's because we want you guys to put your own things in the struct. We're not gonna like force you to put in some doubles in. We want you guys to work out what you want to put in. Then we have a struct ingredient, which will have kind of the same information as an order, but just for one ingredient instead. And you'll have to put all your stuff in there as well. And one thing to note is you don't need to worry about struct ingredient until you get to stage 2. So that's all the structs that we have pretty much. And we'll move on from there. Okay, so allowed C features. Pretty much everything is allowed in here. If it's not mentioned here and you want to know if it's allowed, just ask on the forum, ask your tutor. Pretty much everything should be allowed. The one thing we're going to stress is you cannot use arrays unless they're char arrays. So arrays and linked lists, they use very similar things, but in terms of what we want in this assignment, we want you guys to use linked lists rather than arrays because they have a different purpose when it comes to actually storing data. So arrays and linked lists both store like data in some kind of order, right? But linked lists can kind of like grow and shrink. And that's what we kind of want with these orders in the pizza. So just note, no arrays unless you're using char arrays. And the reason we're allowed to use char arrays is because we care about strings in this assignment, right? If we didn't allow char arrays, we can't have strings. So as a result, we allow char arrays, but that's the only type. Yeah, so feel free to read through all that if you're worried about anything, but that's all. So we also have a reference implementation. So if you run this command in the terminal, you'll get like a finished program that you can actually run it against and like check different things, but we'll get to that in a second. So in terms of the starter code, we give you guys 3 files to start off with. Now, because we're just looking into like multi-file projects now, this is what assignment 2 is going to be. We have 3 files, a main.c, a pizzeria.c, and a pizzeria.h. In terms of what you guys are actually changing, it's only this file. You only need to care about this one. You're not changing the other 2. In fact, main.c, I wouldn't even look at it. It's confusing. It doesn't make sense. Just know that it's there because we need it. And I'll get into like what main.c does for us in a second. But you don't really need to look at it. It's fine. Pizzeria.h, this is like all the documentation for all the things you're going to have to implement. So this one's really important to look at, but you don't need to change it. And this one's quite a book, so read it cautiously. Don't read it all in one go. It might give you a lot of like information overload. So to get started, make an assignment 2 directory. So go into VLab or whatever you're using, make an assignment 2 directory, go into it. And then we want to copy all the files over. So there's 3 files, pretty much just copy this command, paste it in your terminal. Ooh, that just opened another, okay. Sorry about that. Paste it in. It'll do all these commands, press enter. And then after that's all done, type ls, and you'll see you've got these 3 files here. Now, you might be wondering, like, why are some of these files blue? Why have they got a blue font? And the reason for that is that if you're using the CSE machines, like VLab, or even VS Code over SSH, something like that, these files here will essentially be linked to files that we have on the system as well. So if we change these files, they'll change in your directory as well. So if I change pizzeria.h inside the actual like course directory, it will change it for you. And the reason we have this is that if we find like a bug or there's a typo or we want to clarify something, we'll change it on our end and it'll change on your end as a result here. We don't have the same thing with pizzeria.c because you're actually changing that yourself. You're editing it. So pizzeria.c is what you changed. Main.c, pizzeria.h, don't change them at all. We'll handle all of that. But read through this. So let's move on then. That's just setting it all up. Hopefully that's all right. If you want to make sure everything's fine, copy this auto test command over. Just go paste it in and press enter. You'll get a bunch of red, a bunch of fails, but that's good. Hopefully it runs. Awesome. So if you got 1 test passed, 13 tests failed, then you're all good to go. You've set it up correctly. And if you got 1 test passed, good job. You passed like 1.3% of the test. That's awesome. So yeah, that's all there. If we're going to move along now, we are going to look at the reference program. So I would recommend, before actually even getting started on writing stuff, run this command in your terminal, the 1511 CS Pizzeria. So if you run that, you'll get this whole terminal thing that opens. And the first thing you might want to do is type H and then press enter. And what this will do is we'll open up a bunch of information about all the stages and the different commands you can do for these. So the thing to know with this assignment is you don't need to handle like the actual user command input. The main.c file actually handles all of that for you. You're just handling what that command would like do to our pizzeria. So for example, in stage 1, we've got this O command, which adds an order to a pizzeria, takes in a customer name, pizza name, price, time allowed, all that kind of stuff. And then it'll add the order to the pizzeria. So you don't need to handle the actual like scanning in of the stuff. You're just handling what this would do to the pizzeria. So let's do an example here. I'm going to add myself to the pizzeria. I'm going to say add Rory, that's my name. I want a pepperoni pizza. It's $19.99 or something like that. 15 minutes, that's how long I want to wait for it. If I press enter now, you see order gets added successfully. And I can use this other command that you guys will be implementing, which is P. And this will show you all the orders. So I press P, it prints out all the orders. Obviously, there's only one order at the moment, but you'll see that it's printing out my order like this. And so that's a really nice thing there. So mess around with this, mess around with like all the stage 1 functions before you get started. It'll just make your life a lot easier to understand like what's going on, what's correct, what's not. And then when you want to close the reference program, just press Q and press enter, and there we go. That's all done there. So that's a reference program. In terms of all that, I would read through the rest of these things here, but they're basically just information about pizzeria.c, pizzeria.h. Pizzeria.h is where you're going to be spending most of your time reading, so make sure you read through that, but we won't go through it yet. And pizzeria.c is where you're actually going to be implementing things. So to compile the program, just compile it like we have with other multi-file programs. So essentially, just all you have to do is you do a regular DCC, but instead of specifying one C file, you specify all the C files you want to compile, and then the name of the actual program itself. That's all you have to do. Or you can just copy and paste this command if you want to. That will work as well. Okay, so we'll move on from there. And back to you, Clarissa.
Okay, cool. So as you can see, your tasks are stage 1, stage 2, stage 3, and stage 4. And we'll be looking at stage 1. So just like assignment 1, you can look at the different stages just by hitting the tabs at the top. Pretty cool. Let's see what stage 1 is about. Okay. Okay, cool. So stage 1 covers a lot of the things that you guys have been covering this week. So creating, inserting, and iterating through a linked list. Your lab exercises have been covering those. That's pretty cool. And yeah. So we really hope that every student completes this stage, even though you may struggle with it, because this is pretty early into linked lists. We know you guys have just covered it last week, and that's why tutors are allowed to give you a lot of help for stage 1. They can give you detailed theoretical explanations. We can give you help with the lab exercises that are related to it. We can also even help you debug any issues within your code. Yeah. And so once you complete this stage with good style, just like assignment 1, you would be at around a 30% mark. Okay, cool. So in this okay, so in this stage, you'll be implementing add order, print all orders, and next deadline. So Rory just demonstrated add order and print all orders on the reference implementation. And yeah, so add order will be inserting. So if you guys think about it, right? If you're the 3rd customer that walks into a pizzeria, you want to have, obviously the 1st and 2nd person will get their pizza first. So that's why in add order, you will be adding to the end of the linked list, because the first person will get their pizza, the second person will get their pizza, and then you will get your pizza. And an order will have your name, the pizza you want, the name of the pizza you want, the price that you will pay for the pizza, and the time you are going to wait for the pizza. Okay, cool. And just like Rory has already mentioned, struct order will be empty besides the next pointer in your starter code. So it is up to you to fill that in. And we also have a hint here, just in case you guys are not sure where to start. Okay, cool. So because this is the very first function, we're going to help you guys out by showing by going through the .h, the structure of the comment in the .h file. So if you guys look at the very top, it says Command O. And Command O, just like how Rory was using it in the reference implementation, that's how you call add order in main.c. You type O, you type the customer name, and so on. Yeah, so there are a bunch of like examples here, like what add order should be doing, and then we'll have the inputs of add order. So add order will be given the parameters pizzeria, customer, pizza name, price, and time allowed. You can see the types of each input, and you can also see what their purpose is and some examples. So here, time allowed is 15. This means the customer expects the order in 15 minutes. And it also gives you an example of what an invalid time allowed is. So if a customer says, oh, I'm going to wait for like 0 minutes, that makes no sense. You can't make a pizza in 0 minutes. And that's basically the inputs. And then we'll have the outputs, which are invalid price, invalid time, and success. And you can see that which case that where each thing is returned. So invalid price, invalid time, and success are all hash defined in pizzeria.h. And you will be using those in your implementation. And then at the very end, we have assumptions. So this is very similar to the Week 8 lab exercise fractions. It has the very similar structure of description, input, output, and then assumptions. Oh yeah, Rory will go over the diagrams.
Yeah, actually, there's a question in chat. Price can be 0. Yes, price can be 0. Maybe you got like a free coupon or something. That's our explanation for it. So yeah, just to clarify that, the price can be 0. So moving on then, we've included a bunch of diagrams for a lot of the functions here, just to explain what's going on. So the first one we're including is what happens when you add an order to a pizzeria when it's the first order, right? So this is what our pizzeria looks like initially. It's a struct pizzeria. And it contains one pointer that points to all the orders, but because we've got no orders, it's going to point at null. So that's what it's initially doing here, just pointing to this X. So after adding an order like this, what's going to happen is that our pizzeria is going to get a new order inside of it. And so as a result, we're going to have this new struct order that gets added to our linked list of orders inside our struct pizzeria. So always important to note with this one, because I know that confuses students a lot. Make sure that you understand that we've got a struct pizzeria which contains all the orders. So it contains the head of the linked list, and we use that to actually look through it. So just what's going on here, we've also written like add your own fields here in the diagram. And this is because we don't actually provide those fields, right? We don't provide the name or the pizza name or the price or the time to wait, because we want you guys to do that. So add your own fields here. But for the purpose of the rest of the diagrams, we're going to have our fields as we have pretty much structured it. So you can feel free to copy it if you want, or you can make your own. It's up to you. So moving on, we'll see this is what it looks like now. We've got like customer, pizza, price, time, next inside all the orders. And in this diagram, essentially what we're showing is what happens when you add an order to the linked list of orders, and there's already a bunch of orders inside of it, right? So in this pizzeria, we got 3 different orders, and you can read through them. We've got a bunch of information about them. And then what we're doing is just adding a new order with this command here. And so what happens is that we add it to the end of our linked list. So you can imagine that if you're actually writing this code out yourself, what you're going to do is probably need to like loop through to the end, right? And then add the order. But we won't like obviously go through exactly how to do that. So it's just like some really basic linked list operations just to get you started with the assignment. But this is also a lot to like get your head around. So don't feel bad if you're not feeling too well about this first function. First function will be the hardest, I think, for a lot of people. But as you keep going, it'll become easier and easier. In terms of like how this actually works, I'm going to quickly go over to pizzeria.c. So I'm going to open up my pizzeria.c, and it's going to be this big file with a bunch of stubs, basically, just not things that haven't been implemented yet. But how it's going to be all set up is that you've got your structs here, and you'll notice that we don't have any of the fields in them. We just have like the bare bones stuff, like an ingredient will have a next pointer, an order will have a next pointer, and a pizzeria will have the head of the orders, right? So it's just important to keep a note there. Keep in mind, we've also got the hash include pizzeria.h, because remember with multi-file stuff, you've got to hash include the .h file in the pizzeria.c and in the main.c. So they'll both be linked that way. And then if you scroll through, what we have basically is helper functions up here. If we've written any helper functions, then we're also going to have all the functions you've got to implement. So we've implemented this first function, just creating a pizzeria. It will essentially malloc us a new pizzeria, return a pointer to it. So hopefully that's okay, given the recent content we've learned. But that's how we're going to be creating our pizzeria. Then obviously we set the new orders to be null, because remember that if there's no orders in our list, we have to set the head to be null, just so we know there's no orders. So that's all done for us. And then if we move down to add order, which we were just looking at, it's this function that takes in a pizzeria, a pointer to one, two strings, a double and an int, and these all correspond to the information you've got to store for the order. So you'll fill in this function, and if you've done it successfully, you'll actually be able to add orders to your pizzeria. So you don't actually have to worry about like calling the commands to then call these functions. What happens essentially is that main.c is running all these commands, and then if it sees an O, it's going to try and add an order. It's going to try and call this function. So you don't need to worry about user input. You just need to worry about what these things will be. And so moving on from that, we'll see all the functions for stage 1 are actually here. They're just like not implemented yet. And same for stage 2, you'll notice. And then also for stage 3. And then I will quickly show you guys the .h file, just to show you what add order will look like inside of it. So we're going to open up pizzeria.h, and there's a lot of text in here, so it is very overwhelming, but we'll go through it slowly. So first of all, we have a bunch of hash defines here that are just like useful for us inside our .c file. We put them in the .h because it's usually better just to do that, and our main.c is going to have to know like what things were returned from our function, right? Because we have all these flags to return stuff. So like if it's an invalid price, we return invalid price. So main.c needs to know what's being returned, so we have to include it here. All right, and then inside of here, we have the same structure. It's like stage 1 functions, but then we have these big paragraphs of text that explain them. And you might be like, oh, I don't want to read this much. And it makes sense, but you'll thank us later when you know exactly what the function's meant to do and what it's meant to output in, what it's meant to take as input, as output, what kind of errors you can have, what kind of assumptions, all that kind of stuff. So add order will have all this information as we saw before, but everything's going to be in the .h file. So the next one will be print all orders, and I'll have all this stuff. All right, and we'll go back to the page now. So where is it?
So print all orders. Yeah, so this is very similar to print list. You guys would just be printing the linked list of orders this time instead of a linked list of nodes. And something really, really handy that we have provided you is this helper function called print order. So I know that from like week 1, you guys have been struggling under the wrath of the auto test, saying like you missed a new line or you missed a white space, you accidentally printed out the instead of a. But we are going to help you with that, and we're going to give you print order, which will, given the order's values, it will print it out in the exact right order. So if you remember back when Rory printed out the reference implementation, it's very, very specific. It says Rory ordered a pepperoni pizza, blah, 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 right? So we've provided that for you. And so something else that we want to mention about print all orders is that there is a function inside of it. There is a function call inside of it already, which is a function called to print selected order. Print selected order is a function in stage 2. Do not change it, leave it alone, write all the code above it, and you should be good. Yeah. Okay, cool. So the next function that the final function in stage 1 is this function called next deadline. And what next deadline does is it tells the chefs in the pizzeria how much time left there is until their next deadline. So this will be going through the pizzeria, finding which order has the lowest time left, and you will want to return that. Or do you want to show them the diagram?
Yes.
Yeah. So in the diagram, you guys can see that the lowest time among the 4 orders is 10. So you will be returning 10 from this function. Okay, cool. So that is stage 1. And that is 30% of the assignment done. Congratulations, guys. So stage 2. So stage 2 will be a little bit more complicated, and you'll be manipulating the fields of the structs within a linked list. So as you guys recognize from the first one, we were only inserting them and iterating through them. We were just reading from them after we inserted them. We hadn't changed them. So now we will be changing them in stage 2, and we'll also be starting to look at the 2-dimensional linked list. We will be covering 2-dimensional linked lists in tutorials in week 9. So don't worry if you are feeling a little bit scared of them. We will go over them. So even though this stage is a little bit more difficult than stage 1, we really hope that most students can complete this, and most of it, if not all. So if you complete the first, I think, half of stage 2, you will get around 50%. And if you complete all of stage 2, you will get 65%. The specifics are at the very bottom in the assessment section. And just like stage 1, tutors can help you as much as they want. So there are a lot of functions in stage 2, as you guys can see. There's a total of 5. Select next order, print selected order, select previous order, add ingredient, and calculate total profit. So let's look at select next order. So the details of the function can be found in pizzeria.h, just like every other function. So after you kind of look at this summary, you'll want to go to pizzeria.h, and you want to look at the specifics as you code. And yeah, so what is selection? So if you guys think of like when you guys are in a Word document, right? When you select some text to bold it, or when you select some text to highlight it, that is exactly what this order is going to be doing. We're going to be selecting an order, and we're going to be making changes to it. Instead of making a change to a sentence, we will be making a change to that order. And this is really, really important for every other operation in stage 2 and so on. So yeah. Okay. And then, yeah, so this is like when there is no selected order, that'll be null. And then if there is a selected order, yeah, very, very cool. So select next will be moving from no orders to the first order, to the second order, to the third order, and then back to no orders. It's kind of like a cycle. Okay, cool. Also, Rory, if you have anything else you want to add, feel free to jump in.
Yep.
And then the second task in stage 2 is printing the selected order. So this one you will have to be writing. We couldn't help you guys with this one. Couldn't give you a helper function for this one. But so we have started. So if you go to the starter code, you'll be able to see that there is a printf in that code, and it'll say there is no selected order. And then it is up to you guys to change it up and make sure that it works properly according to select next. Okay, cool. And we have a bunch of hints here. If you guys are unsure how to pronounce certain things, here they are. Oh, and something to mention here is that there is a print ingredient thing here, but since you guys haven't implemented print ingredients yet, feel free to skip this part and then go back to it once you have implemented ingredients. Okay, cool. And then 2.3, select previous order. So this is the exact same as select next, except now we're going reverse. So if we think about it, right? So select next started from the first to the second to the third. Now we'll be going from the third to the second to the first. Cool. And then now in 2.4, this is where we begin the 2-dimensional linked list, where we begin to add ingredient. So here, just like with add order, you guys will have to fill in the struct of ingredients. And something really, really cool here is that now we'll be working according to the selected order. So when we add ingredients, we want to be adding to the selected order. So as you can see, Rory's showing the diagram. The selected order, I'm not sure if it's super clear on the stream, but if you guys have the spec open, you guys can see that the selected order is actually highlighted in green. So, and then once Rory scrolls down to the after image, you can see that the ingredient has been added to the selected order. It's been added to the one that's highlighted in green. And this is the kind of thing that we're using selection for. Cool. And something really handy about ingredients is that you'll be adding them in order of their name. So I think you guys were working on it. Which lab exercise was it this week, Rory? The one with the strings?
List contains?
Yeah, so list contains. You guys were working with linked lists and figuring out the strings, right? Which string matched which. So now you guys will be using that skill. But now instead of just looking through the linked list, you guys will be adding to the linked list. So here we have the struct ingredient linked list. It has a base, mozzarella, and pizza sauce. And now if we add green pepper, we are going to want to add it between base and mozzarella because that's in alphabetical order. Yeah, so there are a bunch of hints here to help you guys figure it out. So if you scroll to the bottom, using stir-comp would be very, very useful. And also we have a function prototype here. If you guys intend to attempt stage 3, you might want to create a function like this so you can reuse that code. Yeah. And then finally, stage 2 is a lot, we know. You have this last function, which is calculate total profit. And this would just be looking through the selected orders linked list of ingredients and doing a little bit of maths, doing a little bit of adding and subtracting. The specifics can be found all in pizzeria.h.
Yeah, I recommend reading the example in it because it's confusing to understand, but once you do it, it makes a lot of sense, I think. But yeah, read through the .h file. Very big, but very useful. Ooh, so that's the end of stage 2. We're going to move on to stage 3 now. So let's go up here. So stage 3 is a bit more advanced than, well, not a bit more, I would say a decent amount more advanced than the previous 2 stages. So why does this stage exist? Well, this stage is actually going to be like testing your ability to manage memory and delete from a linked list. So it hasn't really gone over too much yet, but when we have something like a linked list, one of the really good things we can do with them is actually like delete things that are like in the middle of them or at the end or at the start. And so we're going to be testing your ability to do that, as well as using the free function for things that are malloc. So if you guys remember, when we use malloc, we're allocating memory for us so we can like use it and manage it manually. But when we're done with that memory, we need to free it, right? So we're going to be testing you guys on freeing different orders and ingredients and making sure there's no memory leaks with them. So that's a big part of stage 3. And then there's also going to be some more advanced applications from stuff we've seen in stage 1 and 2, just to help you out with understanding linked lists to the fullest. So these skills aren't essential for passing the course, but they are quite good in like helping you guys out with just understanding a lot of the things to do with C and managing your own memory, which is a really important thing, but also linked lists themselves, if you don't understand the basics of them, it's more important to just focus on the earlier stages rather than trying to do all these advanced things. So we kind of expect students who are going to take probably further comp courses such as COMP1511 and 2521 to try to attempt this stage. But once again, if you're struggling, then don't worry if you can't do the stage, that's perfectly fine. In terms of what tutors will do to help you, we can still give you like decent theoretical explanations of what to do, and then also give you lots of helps and labs and stuff like that. We're also going to help you out with debugging, because when it comes to linked lists, there are a lot of debugging problems, and we're going to try and help them out as much as we can. However, we will prioritize students that are on stage 1 and 2, as that is the more core stuff for the course. So just keep that in mind. If you complete the stage with good style, it's worth around a 90% mark. So that's quite high. And it's somewhat reflective of how difficult the workload is as well. So in the stage, you're also going to be implementing 5 different functions. So still quite a bit, but hopefully some of them are a bit easier than others, so hopefully it evens out. So the first thing that you guys will be implementing is cancel order. So details will be in pizzeria.h, but essentially cancel order will just be when it's called, and I think it's the C command. What's going to happen is that whatever is the selected order, that order will be canceled. So that will pretty much be deleted from the entire pizzeria, including all its ingredients, which is really important to understand. And it just will no longer exist in it. So the diagram probably helps out the most here. So we've got this whole pizzeria. We've got all these orders and ingredients. We've got this selected pointer that's pointing to this second order. So we know the second order is selected, right? So if you want to cancel out this, if you want to cancel the selected order, then all we have to do is use the C command. And what's going to happen is this entire order will be deleted. It'll be freed from memory. Everything is gone. And then your pizzeria is essentially going to fix itself up so that this first order now is the next pointer to the third order, or what it was before. It's now the second order. And you'll notice that the selected pointer will now be at the next order. So a lot of stuff going on here, a lot of moving parts. But essentially, when you go and you free the selected order, you need to make sure that your pizzeria stays intact. And something you'll probably come across with in this assignment is you'll free the selected order, and then everything after it is just like disappeared from the linked list. Everything's gone to chaos. You've got memory leaks everywhere, and that will just happen. But yeah, this is a really good exercise, especially if you want to fully understand how to use more complex things such as linked lists and how to properly manage them. So yeah, really useful one. Yeah, read through those examples. They're really nice just to show what's going on in terms of the actual solution. The next one is freeing the pizzeria. So once again, details are in pizzeria.h, and you'll notice that there is very little information on this webpage. And that's intentional from us. We want you guys looking at the .h file more than the webpage. The webpage mostly just includes diagrams and examples if you need them, but actually explaining what's going on, go read the .h file, because nothing really is explained yet for free pizzeria, besides like a general overview. So basically, free pizzeria will essentially be freeing every single thing that you have in the pizzeria. And this will be called essentially when you quit the program, when you put in the Q command. So why do we do this? Well, when we create a pizzeria and we put all these orders in, all these ingredients in, when we want to actually like exit the program, we don't want to like be just leaving memory allocated, because that's just bad practice from us as good programmers. So what we do is we just free all the memory that we have to do. Now, it's important to note that you can't just like call free on the pizzeria here. You will need to free every single individual order, every single individual ingredient. Otherwise, it won't work. So there's the real challenge there. This one's always a fun one though. So good luck with that. Yeah. All right, refill stock. This is where we add more stuff to our pizzeria. So there's going to be another linked list essentially. And I find it useful to just open straight up the diagram. Right now we've got like this whole structure where it's just like the Struct pizzeria, the orders, the ingredients, those have all been just like dotted out because we're not caring about that at the moment. But we've got this new linked list called the stock, and that's going to be in the pizzeria. And that will essentially be a linked list of more ingredients. Maybe I'll zoom in here actually. And so the stock will point here, and it will create a new linked list of ingredients that we're going to be using for later parts of this stage. And so that's what it looks like. What I will note here is that the order that you insert into the stock is the same as you would insert ingredients into an order. So they're the exact same. And that's also why we have the hint in stage 2 about creating a general function for inserting into a linked list of ingredients. It's because you need to do the exact same thing with the stock here. But once again, you don't actually need to do that if you don't want to. It's just recommended if you're going to attempt it. And then once again, if you're going to refill an ingredient, that's the exact same. what happens is just like merges it together like this. So instead of adding a new ingredient node, what happens is that they get kind of put together into one ingredient node. All right. Also, yes, if you implement the stock, remember to free it in free pizzeria. So you're going to have to go back to the free pizzeria function and free all the stock as well. Otherwise, you'll get a memory leak. So good hints there. All right, so fourth task is printing the stock. So this is just here so you guys can ensure that your stock's actually correct, right? Because it's great adding things to the stock, but you need to make sure it's right. So all this does is that you'll add all this stuff to the stock. You don't really need to worry about all this. This is just like adding to the stock. It's refilling like this. And then like you print out the stock with S and it'll show you all the ingredients inside of it. So that's just what printing is there. And the next part of stage 3, this is where it gets a bit more complicated, but essentially we're going to now like utilize the stock to actually do things. So we've got this function called CANCompleteOrder, and essentially what it's going to be is that you've got orders, you've got ingredients in those orders, and you've also got the stock. Now, this function essentially is just going to return whether you can complete an order or not. Now, the condition to actually complete an order is if there's enough ingredients in the stock to satisfy the ingredients in the order. So that's the whole exercise there. It's a lot to think about because you're going to have to do a lot of different things with both linked lists in the stock and in the order. So it's a lot to think about, but once you get that working, I think it's pretty rewarding to do. So yeah, examples here if you need them, but it'll essentially just return success or I'm not entirely sure what it'll return. Read the .h file and it'll tell you. But yeah, move on from here then. So stage 4, this is where it gets like quite hard. We don't really expect many students, or not a majority, to do this anyways. So stage 4 tests your ability to perform more complex linked list operations, as well as manipulate strings in more advanced ways. These skills are not essential to pass COMP1511, but if you want a challenge, feel free to go and do these. So yeah, we just expect students that want a greater challenge from the course to attempt this stage, but we don't expect like a majority of the cohort to do it. What help can we give to you guys? Well, for stage 4, because it's such a late stage, we can give you like theoretical explanations of like what's going on in the function, so you can like get a start on. But we can't really give you specific advice. So we can't really tell you what code to put in, what to write, as well as like help you with very specific bugs to do with the function. But we can give you like little explanations of what the function is overall. So if you do complete stage 4 with good style, you're looking at 100% as a mark, as you would expect if you finished all of them. But remember that stage 4 is only worth 10% of the entire mark. So just think about whether it's worth it or not to do it. I know a lot of people have different subjects to do, so make sure you're not like neglecting those, even if the pizzeria is fun to do. All right, so in this stage, there's 3 functions you guys are gonna have to do. Complete order, save ingredients, and load ingredients. So complete order kind of branches off from stage 3. So we had the can complete order, which just like it returns whether an order can be completed or not. Complete order is essentially the same thing, except you actually complete the order if it's completable. So using that knowledge, you're probably gonna have to utilize the can complete order. But essentially what's gonna happen is completing an order will remove the order from the linked list, as well as remove the ingredients from the stock. So it'll subtract the ingredients from the stock. Doesn't necessarily mean the ingredients are removed completely, but it'll subtract them. And then the key thing here is that if the stock has 0 of an ingredient, you'll have to remove it from the stock list. And so that's the crux of the problem there, I believe. For the last 2 functions of stage 4, you guys will actually be given 2 extra files here. So we've got savestring.c and savestring.h. Read through them. Essentially, they're just like a small library to save strings to a file. So you guys don't need to like do any file stuff, but you essentially give these functions are string, and then it'll save it as a file. You can also load a string from a file. And so they'll be useful for the next two functions. All right. So to download those, just like the other ones, you just run these commands. You don't change them. They're just there to help you out. You don't change them at all. Feel free to read through them if you want, but they're a bit confusing. If you're at that stage, you might want to read through them, but it's not really needed. And once you've actually got these files and you want to be compiling your code together, you're going to need to include savestring.c in your compile command. So you're going to have to compile all 3 C files to actually get your pizzeria. Okay, so stage 4.2, essentially what it's going to be is save ingredients. And what that does is that you have a selected order and you just call the save ingredients command, and it will save all the ingredients in that selected order to a file as a string. So a lot of string manipulation on this one, but it's really interesting. So like you've got an entire pizza, like you've got a base, you've got some pepperoni, you've got some mozzarella, all that kind of stuff. You're saving that to a file that you'll be able to use later in the next function, which is load ingredients. And so load ingredients will actually load a string from a file, and then what you'll be able to do with that is add the ingredients to the selected order. So it's going to load all these ingredients from the file, add them to the order, and there we go. That's everything. So read through these examples if you want. These hints will be helpful, so make sure you read them, and you'll probably have to utilize these functions we've told you to use, unless you find another way, which is possible. But yeah, that's everything there. So that's all stages there, 1, 2, 3, and 4. Now what we're going to do is let's go back to the slides. Onto the tips and tricks part. So Clarissa, did you want to start off with this? Do you have any tips and tricks for the assignment?
Yeah, so I'm pretty sure everyone is already telling themselves, start early, because you don't want to find a bug in the middle of the night before it's due, and realize that my curly bracket is missing and I have no idea where my missing curly bracket is. So that's like really important for all coding assignments, but for this specific assignment, for assignment 2, really try to draw diagrams. So we've given you guys a basis on what your diagrams could look like, but you don't have to make them as complicated and as thorough as ours. You can just make some simple circles, some arrows, and some X's. That's it. And it's really, really helpful to use. When I do linked list diagrams, I like to use Microsoft PowerPoint because copying and pasting nodes is easy, and also moving the arrows is easy, and I can just follow along with my code. If my code says cur is equal to cur next, I like to move my cur pointer to the next one just to follow along with my code. And also something else that I did when working on the assignment 2 when I was a student was I always had the .h file open and I never opened the main.c, because you can complete this entire program, you can complete this entire assignment without ever looking at the main.c. So yeah, those are my tips. Rory, do you have any?
Yes, I had a few. Auto tests. So we provide you guys with a lot of auto tests. I think it's like 70 or so for the assignment. But I will note here that we do intentionally leave out some edge cases that you guys might not have considered. So make sure you're actually testing your code thoroughly, because there will be some actual tests that we haven't provided that you might fail. So we do this because it's important to learn how to properly test your code and make sure it's working. We're not going to make you like write your own test or anything, although it could be useful if you do. But just like try out different things with all your commands. Make sure everything works as you expect it to. And use the reference implementation just to see what should be output when you input a certain thing. That's a really important thing, especially if you don't even know what's going to happen. Just use the reference and that will work out fine. Because that's what we're going to mark you against, the reference solution. Next thing, labs are very, very helpful for this assignment. So week 8, especially, it's just a bunch of linked list labs to get you ready for assignment 2. And I would recommend doing those first before you start the assignment. But also a lot of the exercises in the labs are very similar to the ones we have in the assignment. So make sure you look at those and understand how they work, and then you can kind of like convert it over. The next thing I had, the .h file is like a book. So I would say skim it first, but only read thoroughly for the parts you are actually doing at that current point. Because if you read it all at once and you try to understand it all, it's going to be way too much overload. Your brain's not going to really be able to handle it. So I recommend a little skim and then just read each function when you're up to it. I wrote here, because I want to also push this, diagrams. Make diagrams with linked lists. They're very, very helpful. I remember when I did assignment 2, I think I could only pass a lot of the functions if I actually started drawing things out. Because as soon as you draw out like your code to see what's going on, you'll realize the problem easily. Like when you've got a pointer and it's going looping through and then something weird happens, if you actually draw out the diagram to see what's happening, it's usually apparent very quickly. So that's another thing. Next thing, read the assumptions in the .h file. So every single function will have an assumptions header. Read those if, actually just always read those for each function.
Read the entire function comment.
Read the entire thing, yes, even if you don't want to.
You won't regret it.
Yeah, and I think that's everything from me.
Also, Shrey, if you have any assignment 2 tips, feel free to jump in as well.
Oh wait, no, my mic's muted. Yep, there you go. I think you guys have covered all the things I was going to say. We say diagrams a lot, and you'll see when you ask for help in help sessions, tutors will often use diagrams to explain concepts to you. Linked lists are a very visual concept because you have a lot of moving objects. Speaking of help sessions, make sure you go to help sessions early. Assignment 2 is when, towards the later weeks of the term, we have a lot of tutors in the help sessions, but there are also a lot of students in the help sessions, especially when the assignment's due the next day. So please go to help sessions early. Ask on the forums. There'll be a whole team of people on the forums looking to help you with any of your queries. If you get stuck at all, ask for help. We can't help you unless you ask for help, and that is a very important piece of information that people need to understand. But overall, enjoy the assignment. Rory and Chris have worked really, really hard over the last couple of weeks in getting it set up, and you should all hopefully have a great time doing it.
So, thanks for that.
Okay. So, thank you for coming to the lecture. Thank you for watching the recording. And if you have any final questions, feel free to drop in the chat. Rory, Shrey, and I are here to help. Yeah.
Yeah, we'll stick around for maybe a few more seconds just to see if there's any last minute questions. But yay. How good is Thursday nights?
How's everyone Thursday nights? It's good.
Cool, alright. Well, it looks like there's no more questions, so I'll probably end the live stream about now.